Fusion Mobile, quality e-learning experience on the go.
Fundamentals of electronics. Some textbooks call it basic electronics. This is the study of, or let's call it the physics of semiconductors. Here we'll talk about conduction in solids. First, I would like you to really understand the three basic materials we have. We have the insulators. Insulators are materials that cannot conduct electricity. We have conductors. Conductors are materials that can conduct electricity. Then we have semiconductors. Semiconductors in their normal condition cannot conduct, but on accepting little energy they will be able to conduct. And today we are dealing properly with semiconductors. Semiconductors, these are materials, or we call them an intermediate material between the conductor and an insulator. And we have types of semiconductors. There are two types of semiconductors. We have the intrinsic semiconductor and we have the extrinsic semiconductor. Extrinsic semiconductor. Intrinsic. These are pure semiconductors without impurity. Extrinsic semiconductors are conductors with impurity. Doping. This is the process of adding impurity to a pure semiconductor in order to enhance the conductivity. We have the donor impurities and we have the acceptor impurities. Majorly, these impurities are group 3 elements and group 5 elements. Then we have the p-n junction diode. If we have this to be a diode, this is positively charged and this is negatively charged. This one is called the p-n junction diode. Here is the junction. And whenever you connect this to EMF, something happens. If you keep the battery such that we have positive this way, this is positively charged and this is positively charged. Positive to positive, there will be repulsion. So you have these positively carriers running over to the junction, and also negative negative, you have these negative carriers running over to the junction. And now at the junction, what happens? We have much number of carriers and the galvanometer would deflect to the right, showing more number here, and this is called forward bias. But if I suddenly change it, look at the one down, here now is negative and here is positive. Positive will attract negative and they will be running out this way. And here, negative will attract positive and they will be going this way. Now, what happens to the center or the junction? It will be deficient from carriers. At that moment, the galvanometer will deflect to the left, showing deficiency. In the next class, I need to take you further into transistors. But before then, I would like you to take basic study on fundamentals of electronics, most especially conductors, insulators, and semiconductors, based on the energy gap as we discussed earlier. In the first part of this lecture, before we start coming over to this side, we've discussed that the energy gap of an insulator is too large that electrons cannot move from the valence band to the conduction band. While that of semiconductors, the energy gap is small, such that on its own it cannot conduct. But when little energy is being absorbed, it will move over to the next one, and it will move from valence to conduction, thereby enabling conduction. That is for semiconductor. But for conductors, there is an overlap between the conduction band and the valence band. So since there is an overlap, it conducts even on its natural condition. My dear, it may please you that we've come to the end of physics as a subject, and the last topic is the fundamentals of electronics. Hope to see you again. It is Sayudi Jesus here. I would like to see you any day, anytime. Log into Fusion Mobile Nigeria, you meet me there, or you can meet me through my website www.wunderbaik.com. I repeat, www.wunderbaik.com. Okay, have a wonderful time. See you again on Physics Clinic of Fusion Mobile Nigeria. My respect to all the lecturers out there, my respect to all the students out there, and my love to all Nigerian physicists. Physics is wonderful. Physics is interesting. Physics is the best. Have a wonderful time. See you next time, and remain blessed.